A Japanese mechanic once showed me something that changed the way I think about cars forever. He had just finished restoring a 1982 Toyota Land Cruiser with 490,000 miles on the odometer. He bought it for $200 from a salvage yard outside Osaka. And when I walked around that truck, I could not find a single rust spot anywhere on the body. Not on the rocker panels, not on the door sills, not on the wheel arches, not 1 millimeter of frame corrosion. It looked like a 5-year-old truck, not a 43-year-old one. I asked him how. He walked to his workbench, pulled out a small can, and handed it to me without saying a word. The label was in Japanese. He told me it cost less than $2 to treat the entire car. I had spent over 20 years working on American cars at that point. I'd watched customers come in with a rust bubble the size of a quarter behind their rear wheel and leave with a bill for $1,200. I'd watched that exact story happen hundreds of times. A bubble the size of a quarter becomes a panel the size of your hand by the time the body shop is done digging. Rust that started as nothing and turned into a 4-figure repair, preventable every single time, for about $2. Nobody ever told them, not their mechanic who saw the car every spring and said nothing, not the dealership that sold them a $300 rust-proofing package at delivery that sprayed the exposed undercarriage and left the hollow body sections completely untreated, not the manufacturer that designed those drain holes, ran the corrosion tests in the engineering lab, and knew from day one exactly which panels would fail first and in which order. Because rust does not care about your warranty. It does not care about how new the car is. It does not wait until you have paid off the loan. It starts the first winter, inside panels you cannot see, and it works for years before it ever shows on the outside. Here's the part I cannot fully explain in this video. There is one specific application step, the exact step that separates a car that reaches 500,000 miles from one that rots out at 60,000, that does not work in a YouTube format. It requires vehicle-specific diagrams, exact entry point measurements, and a walkthrough I have built out in the Auto Research Guide. Link is in the description below, but let me show you where this secret actually comes from, because rust is not bad luck. It is a business model. American body shops and repair facilities pull in billions of dollars every year from rust-related work. Every bubbling fender, every eaten-out rocker panel, every corroded frame rail on every car in the Rust Belt is revenue. And the moment you know how to stop rust for $2, you become the problem they never planned for. Japan has a rust problem that Americans rarely think about. The Japanese coastline runs for nearly 18,000 miles, and the majority of Japan's population lives within a short drive of the ocean. The humidity in Tokyo and Osaka rivals Miami and Houston. The Northern Islands get winters as brutal as Minnesota. Salt air, coastal humidity, severe temperature swings. By every measure, Japanese cars should rust at the same rate as anything driven in Ohio or Michigan, and yet Japan consistently produces the longest-lasting vehicles on Earth. In documented surveys of high-mileage vehicles, Toyota and Honda dominate the list of cars confirmed at 300,000, 400,000, and 500,000 miles. Not because of some secret engine formula, not because of a superior grade of Japanese steel, because of something that happens inside the panels of the car that you cannot see with your eyes. Right now, while your car is sitting in the driveway, there is water trapped inside it, not in the engine, not in the cabin. Inside your door panels, your rocker panels, your A-pillars, your B-pillars, your quarter panels, your frame rails. Every hollow body section on your car is collecting moisture every time it rains. Every time you wash the car, water runs down the outer panel and pushes in through seams and gaps. Every time you drive through a puddle, spray goes up into the rocker panel cavities and door bottoms. That water sits. It collects road salt, which makes it dramatically more corrosive than plain water. It collects dissolved oxygen, which is the only ingredient rust actually needs, and it sits in direct contact with the bare steel on the inside surface of your body panels. The factory primer coat on the inside of your doors and rockers was applied to meet a production budget. It is a few thousandths of an inch thick. It was never designed to last 30 years of wet seasons. This is the actual physics of why cars rust, not the weather. Stop. I need to be honest with you here. What I just showed you can save the average car owner between $800 and $2,000 in rust repair costs over the next 5 to 10 years. That is what I can show you in a YouTube video. But there are 3 specific things I'm not going to be able to cover here. First, the complete cavity injection guide for the 22 most common American and Japanese vehicles, with exact entry points, correct tube lengths, and diagrams showing how each body section connects to the next. Second, the 3 early warning signs that your rocker panels are already corroding from the inside out right now, signs that a mechanic notices during a routine oil change, but will never mention until the repair is already a 4-figure job. Third, the single most common mistake that turns a rust prevention treatment into a rust acceleration treatment, where the wrong technique traps moisture inside the cavity instead of displacing it and speeds up corrosion by a factor of 3. If you only watch this video, you have the concept. The Auto Research Guide gives you the complete execution. Oil changes, brakes, battery, tires, and rust prevention all in one place. One access, every guide, permanent. Link in the description. Now let me show you exactly what goes inside those cavities. Starting in the mid-1970s, Japanese automakers began injecting a thin, wax-based solution into the interior surfaces of body cavities at the factory before vehicles were shipped. Into the doors, into the rockers, into the A and B pillars, into the quarter panel sections and frame channels. The key property of this wax is that it never fully hardens. That sounds like a flaw. It is actually the entire point. A hard coating cracks from road vibration and temperature cycling. And when a hard coating cracks, moisture enters the gap, gets trapped underneath the coating, and the steel corrodes in a sealed, oxygen-rich environment. The result is rust that spreads faster than on completely untreated metal. A wax that stays slightly flexible moves with the metal as it expands and contracts through every season. It seals micro cracks before they open. It displaces water by a fundamental chemical property. Oil and wax repel water. Any moisture that enters the cavity is pushed toward the drain holes. Nothing sits, nothing stagnates. The oxygen supply to the metal surface is cut. If you have made it this far, you understand what has actually been happening inside your car for years. Is this overview enough for you, or do you want the complete step-by-step guide for your specific vehicle? The Auto Research Guide shows you what I cannot show in any YouTube video. Rust prevention, oil changes, brakes, battery, and everything coming next. Link below. Now here's the part you have been waiting for. The reason this technique costs about $2 is that you do not need the pressurized factory injection equipment to do it yourself. A standard 12-ounce aerosol can of cavity wax costs between $8 and $15, but you only use 1 to 2 seconds of spray per cavity, and a single can treats an entire car. The amount of product used on an average vehicle works out to roughly $2 of material. That is the $2 secret. Not a product, a technique. The knowledge of where to spray and how to reach body cavities that have sat untreated since the factory floor. And why almost nobody in American auto culture ever tells you this. Here's exactly how to do it, and we are going to start with the single most important section on any vehicle, the one that fails first and costs the most when it does. Start with the rocker panels, which are the long horizontal steel sections that run directly below the doors on each side of your vehicle, connecting the front wheel arch to the rear wheel arch. These panels sit in the direct splash zone behind your front tires and ahead of your rear tires, which means every puddle, every winter brine spray from the car ahead of you, and every high-pressure wash cycle hits them repeatedly. Every manufacturer installs small drain holes at the bottom seam of the rocker panel, and you will find them by looking upward at the underside of the rocker while the car is raised on a jack stand or a set of ramps. The drain holes are typically small circular or oval openings between 1/4 and 3/8 of an inch wide, spaced roughly every 12 to 18 inches along the full length of the panel. Take your extension tube, which is the thin plastic straw that comes stored in the cap of almost every aerosol can, and slide it up into the drain hole while orienting the can so the nozzle points upward. Press the nozzle for 1 to 2 seconds, then pull the tube out, move to the next drain hole, and repeat the process until you have covered every opening along both sides. You will hear a distinctive misting sound from inside the panel as the wax atomizes and coats the interior metal surfaces. And sometimes you will see a faint drip emerge from a neighboring drain hole as the wax finds the lowest point. When you see that drip, it means the wax has fully coated the internal cavity from where you sprayed all the way to that exit point. And that is exactly what a complete treatment looks like. Now move to the doors, which are the second most critical area on any passenger vehicle because water enters door cavities constantly through weather-stripping gaps and window channel drainage, yet almost no car owner ever treats them. Every car door has at least one drain hole located at the very bottom corner of the interior door frame, and you access it by opening the door fully and looking at the bottom edge of the door from below and slightly behind. You will see 1 or 2 openings, typically about 3/8 of an inch in diameter, and you insert the extension tube and press the nozzle for 1 full second while pointing the can upward into the cavity. The wax travels upward through the cavity by both pressure and surface tension, coating the inner door skin, the inner panel brace, and the lower window channel reinforcement all in one application. This is the step that mechanics at the best body shops in Japan perform every single spring as part of basic vehicle maintenance. And it is a step that most American service advisors have never once mentioned to a customer. Now move to the wheel arches, where the situation is more complicated because most American vehicles have a layer of factory-applied undercoating in this area that creates a false sense of protection. That factory undercoating was sprayed at the assembly plant in a thickness of roughly 40 to 60 thousandths of an inch, and it is effective when intact. But road debris impact causes it to develop micro cracks and small chips over the first few years of driving. Once a crack forms in the undercoating, moisture seeps underneath and cannot escape, because the surrounding intact coating seals the moisture against the bare steel in a trapped oxygen-rich environment that accelerates rust at a much faster rate than open-air corrosion. The quick diagnostic test is to press your thumbnail firmly into the undercoating in several locations around the wheel arch, and if it feels slightly rubbery and springs back, the coating is intact, and you only need to address any bare spots. If the coating crumbles, flakes, sounds hollow when tapped, or your nail sinks in without resistance, moisture is already working its way beneath the surface, and you need to address that section before applying any new treatment over it. Now the frame rails, which is where this conversation becomes most important for anyone who owns a truck, a body-on-frame SUV, or any older American vehicle they plan to keep for another 10 years. Frame rust is the single most expensive rust repair category in the automotive industry, with full frame replacement or major structural repair on a half-ton pickup running anywhere from $2,000 to $12,000 depending on the extent of damage and labor rates in your area. It is also the most entirely preventable category of rust damage, because frame rail sections are large hollow box channels that can be accessed and treated relatively easily if you start before corrosion has a chance to develop. Most full-size trucks and body-on-frame SUVs have access holes along the frame rail sections that were used during the assembly process, and some still have the original rubber plugs that a flathead screwdriver can remove. Spray into these access points from both ends of each frame section, using a longer extension tube if you have one, and you want the wax to coat the complete interior length of every channel in the frame. For trucks that live in states where roads are salted from October through April, the recommended treatment schedule is twice per year. Once just before the first hard freeze when salt first goes down, and once again in early spring after the accumulated salt and moisture from the full season has peaked. The total treatment time for an average sedan or crossover is about 20 minutes. Once you know what you're doing and where all the access points are located on your specific vehicle. For a full-size truck or body-on-frame SUV with longer frame sections and more cavity areas to cover, plan for 40 to 45 minutes the first time through. Now let me tell you about 4 specific areas that even experienced DIY mechanics and professional rust proofers consistently miss, and these 4 areas are where the most surprising rust failures tend to appear years after a vehicle has been treated everywhere else. The first missed area is the A-pillar, which is the vertical structural column on each side of the windshield that joins the roof to the front door threshold. Inside that column is a hollow cavity running the full height of the pillar from the base of the door sill all the way up to where the roof rail begins, and that cavity collects moisture at its base with nowhere for the water to drain because most vehicles have no factory drain hole at the pillar base. This is one of the earliest areas where serious structural corrosion begins on vehicles in wet climates. And by the time it becomes visible as a bubble at the base of the windshield trim, the rust has usually been spreading inside the pillar for 2 to 4 years already. Access the A-pillar cavity by opening the front door completely and pulling back the rubber weather strip at the base of the door frame, which on most vehicles reveals a small gap between the outer body panel and the door threshold, where a thin extension tube can reach into the pillar cavity. The second consistently missed area is the rear quarter panel cavity that sits directly behind the rear seat on sedans, coupes, and hatchbacks, which is a fully enclosed metal section with no factory treatment and no drain access in the vast majority of passenger vehicles. This section traps condensation from temperature changes and holds it against bare steel for months at a time. And the typical failure mode here is a rust blister appearing on the exterior painted surface above the rear wheel arch, which is one of the most expensive single panel repairs at any body shop. The third missed area is the trunk floor cross brace, which is the hollow horizontal structural member that runs across the underside of the trunk floor on most sedans and is completely inaccessible from below without removing the spare tire and lifting the trunk liner. Accessing it through the spare tire well or through a trunk drain plug, if your vehicle has one, allows you to spray the interior of this brace, which would otherwise sit collecting humidity year-round with no ventilation and no treatment. The fourth and most consistently overlooked area is the lower section of each B pillar, which is the vertical column between the front and rear door openings on 4-door vehicles. Road salt spray from the front tires reaches the base of the B pillar on every wet winter drive, and the absolute lowest point of the column acts as a collection reservoir for water that has no exit because most vehicles have no drain hole at the very base of this pillar. If your vehicle has a small opening at the base of the B-pillar door threshold, use it. If it does not, a 2mm pilot hole drilled with a hand drill creates the access you need, and covering it afterward with a rubber body plug takes about 30 seconds at any hardware store. Now, let me explain the documented history behind why Japanese vehicles show this corrosion protection advantage so clearly and consistently across decades of ownership data. Toyota formalized cavity wax injection as a factory production standard in the late 1970s, initially on vehicles destined for export to high humidity markets, and later expanded the process to all production lines. After corrosion warranty claim data showed the method was dramatically reducing field failures at every mileage threshold, Honda developed a closely parallel process, with their engineering resources focused particularly on the door sill and lower rocker sections, where their field data had identified the highest concentration of moisture damage on earlier models. Mazda, whose headquarters and primary manufacturing facilities sit in Hiroshima directly on the shore of Japan's Seto Inland Sea, and whose engineers have dealt with the most aggressive coastal corrosion environment of any major Japanese automaker for their entire history, developed what corrosion engineers widely regard as the most systematically thorough factory rust prevention program in the global automotive industry. The combined result of these factory-level engineering decisions, compounded over decades of production, is a significant and measurable difference in the long-term structural integrity of Japanese versus domestic American vehicles in high-moisture environments. And that difference is not in the steel composition, which is comparable in grade and specification across manufacturers, but in the decision to treat the inside of the car with the same seriousness applied to the outside. Here is the honest and complete picture of what this technique does and what it does not do, because understanding the limits of any protection method is as important as knowing how to apply it correctly. If your vehicle already has through rust, meaning corrosion that has fully consumed the steel from the interior surface through to the outer painted surface and created actual perforation or structural thinning, this treatment does not repair that damage. Nothing short of panel replacement or patch welding addresses metal that no longer exists. But for vehicles with surface corrosion on inner panels that has not yet broken through to the exterior, this technique stops that corrosion from spreading by encapsulating the existing rust, cutting off its oxygen and moisture supply, and preventing lateral migration into adjacent clean metal. And for a vehicle with no existing inner panel rust, this technique applied once today prevents corrosion from forming in those treated cavities for years. In a salt belt state with aggressive winters and roads treated with brine from October through March, retreating annually or every 18 months is the standard that the best independent rust-proofing specialists recommend. In a dry climate with no meaningful road salt exposure and low year-round humidity, a single treatment often delivers 3 to 5 years of verified protection before any touch-up is needed. Here is the final point that most mechanics and every dealership service writer will never volunteer, because it makes their service department's offering look exactly like what it is. The professional rust prevention service offered at body shops and undercoating specialists runs between $150 and $300 for a complete vehicle treatment. They use the exact same cavity wax aerosol cans available at any auto parts store for $10 to $15. They use the same thin plastic extension tubes that come free in the cap of every can. They use the same drain holes and body access points I just walked you through. The difference between their invoice and your $2 material cost is entirely markup and labor for a 40-minute task. The Japanese mechanic who handed me that small can never thought he was revealing anything extraordinary. To him, treating the inside of a car's body cavities was simply how you maintain a vehicle, the same fundamental category as changing the oil or inspecting the brakes. It was baseline maintenance, the minimum standard of care for a vehicle you intend to keep. For the American automotive service industry, the fact that generations of car owners grew up never learning this was not an oversight. It was the predictable consequence of a business model that depends on repair revenue. You now know what that model relied on, you never finding out. If this video changed how you think about your car, share it with someone who owns a truck or a vehicle they plan to keep for 10 years or more. Subscribe, because the next video covers the oil change interval number printed in your owner manual, the interval that is calculated to benefit the manufacturer and the dealership, and the real number that actually protects your engine long term. That one piece of information alone has prevented thousands of premature engine failures. This is what the industry teaches its own people and has never passed on to the people paying the bills.